So welcome everyone. Today I'm going to go through the Fusion 360 machining extension. I'm going to show you some of the things that Autodesk has added to it and how you can use those if you haven't investigated it. They have continually updated it and improved it as we've gone on. And I think there's some nice features in there if you want some additional capabilities that you don't have currently with Fusion 360 and your CAM applications. So my name is Ed Gillman. I work at IMAGINiT as a manufacturing applications expert. That's my mug on the right there. I worked as a mechanical engineer for a while. I've done engineering design work for a variety of different industries, aerospace, medical, product development. And I've also worked with CNC machines and manufacturing process development as well during my tenure doing that. I work at IMAGINiT as an FEA and CAM specialist, so I handle any of our support for CAM products, so everything from Inventor, Fusion, Feature CAM, and PowerMill all the way up. And then I also help with finite element analysis projects and training, so anything with Nastran, Inventor Sim, and Autodesk CFD for fluid dynamics as well. So let's talk a little bit about what these Fusion 360 extensions are. If you haven't in Fusion 360 already, there's a extension browser you can open up. I'll show you guys where this is at. In the extensions, you'll see there's 5 different extensions you can add on to Fusion 360. The prices and timelines vary, but essentially you can get a 1-day trial, or you can also do sometimes a 7-day trial. And you can also purchase the extension in a variety of different lengths. So if you want to just purchase it for 1 week, you can do that. You could also purchase a yearly subscription to the extensions. So it's an additional cost on top of Fusion 360, but you get a lot of really great features built right in. So if you're looking at purchasing a yearly option, just reach out to IMAGINiT. We can get you set up with that. That's the best price, is to purchase it as a yearly extension and subscription, but you can also kind of try it out on a short-term basis if you're not sure you want to commit to a 1-year subscription quite yet. So you'll see in here, we're going to be focusing today on the machining extension. That is going to be adding additional functionality for manufacturing. So adding additional functions for your mill, your lathe, your inspection, whether it's a 3-axis machine, a 5-axis machine. There's a lot of really good toolpaths and additional capabilities built in. You'll also see the nesting and fabrication extension. If you do a lot of sheet metal or wood cabinetry design where you are cutting parts from a large sheet of material, the nesting and fabrication extension allows you to optimize the yield from that sheet, so you can put together an optimized pattern to cut so that you're not wasting material. The generative design extension allows you to do generative design looking at parts and determining what other varieties you can create that still meet your specifications and requirements. So you can reduce weight, improve your product performance, consolidate parts together. And generative design works for additive as well as 2-axis, 3-axis, and 5-axis mill design. So it will give you a concept that you can use to lightweight your design and optimize performance as you go. The adaptive build extension allows you to program for 3D printed, so SLS machines. If you're doing 3D printed metal, you can simulate and set up your print directly in Fusion 360. And then new, they just released this last week, the Manage extension. It used to be called Fusion Lifecycle Management. They've improved it, and they are adding it into Fusion 360 as a way to manage the life cycle of your designs and do change order management and revision control within Fusion 360. So check these out if you haven't already. Obviously, we're going to focus on the machining extension today, but I recommend going in there and seeing what else is available. So let's talk through the machining extension features. There is a lot that you get with this purchase. First off, there's a couple of 5-axis features you gain. These are actually integrated from PowerMill. So if anyone's familiar with Autodesk PowerMill, as well as Autodesk FeatureCam, these additional extension features are actually borrowed from PowerMill and from FeatureCam, and then integrated into Fusion 360. So you get some really high-end capability with this purchase. 5-axis tool orientation controls. You can control the lead and the lean, the position of your head and your holder on a 5-axis machine to avoid collisions and to improve the surface contact of that tool when you're working on a complex mold or a complex 5-axis part. You also get some advanced probing and inspection features, so you can probe for geometry and indicate if the geometry is in tolerance and the position is correct. You can also do surface inspection where you probe for points along a surface. You can then bring the results of your inspection on the machine back into Fusion 360, and you can look to see what is in tolerance and out of tolerance. Auto hole recognition, so some nice automation. Anyone who's programmed a drill cycle in Fusion 360 knows that it's a bit of a task. You have to go through and select each hole. You have to select the tool. You have to select the process. And if you're doing a counterbore hole, sometimes that ends up being quite a process because you have to go through multiple stages to drill it out. Auto hole recognition does that for you. So it recognizes holes, but it also chooses a toolpath and a tool and then creates that program. So hole recognition can save you a lot of time if you're drilling a lot of holes. Steep and shallow finishing. So if you're doing 3-axis work, steep and shallow will look at your surface and it'll determine anywhere you have a steep surface, it'll use a contour toolpath or a constant Z step down. Anywhere you have a shallow surface, so something that's fairly flat and isn't very vertical, it's going to use a scallop toolpath. So that's some more automation that's built into Fusion. It will automatically choose those surfaces for you, so you don't have to go through and create boundaries. If you've got a complex part that you are milling and you have a rotary chuck that you can bolt onto your mill, or it's already set up, you can run a 4-axis rotary toolpath that will simultaneously use the axis with your tool. So if you want to cut a part on your mill, but you want it to continuously rotate the part and cut along the surface, you can do that with a 4-axis rotary toolpath. Delete passes and trim toolpath allow you to go through and take out some features and some passes of your toolpath you don't want. The advantage of trim toolpath and delete passes is you can modify your toolpath after it's been created. When you delete a section of the toolpath using those tools, it doesn't have to go through and recalculate. It will actually just remove that section. It recalculates the lead in and lead out, but it doesn't require you to start over with a whole new toolpath and regenerate it. It only regenerates that specific section. Okay, so I'm going to just give you some additional information about a few of these features, and then I'm going to give you a live demo of how these work together and what to look out for. So with hole recognition, I'm showing this plate here that has about, I think there's like 12 holes. Some of them are counterbored, and they are different diameters. So we have several different diameters. We have a counterbore, we have a through hole. This is something that when I just went through and I programmed with a default drill strategy. So the standard Fusion 360 CAM platform, I actually counted the clicks. It took me about 80 clicks to do all of those holes. There's probably a few ways to speed that up a little bit, but in general, you just go straight into programming. It's going to be somewhere around 70, 80 clicks. It took me about 10 minutes. Again, I'm guessing it'd be somewhere in that 5 to 10 minute mark. But this time it took me about 10 minutes to actually go through and select all the tools, select the tool path. I went and I had to adjust the bottom height of all of those. It took me about 10 minutes. When I used the hole recognition with the machining extension, it only took me 10 clicks, really just opening it and then modifying a couple of features. And it programmed all of those holes perfectly in about 30 seconds. So if you think about it, if this extension, if you were to purchase a yearly subscription, it's about $1,600 a year, but that comes out to about $4.38 a day. So if you're going to be doing, let's say you're programming 10 parts in a day, you know, if you're saving 10 minutes or so on each one, you know, you can end up saving hours over the course of a day. And over the course of a year, that really adds up. So for, you know, a little over $4 a day, you can really save yourself a lot of time. So just something to think about. This is one of my favorite parts of the machining extension, because anytime you're automating hole drilling, it's going to be a good day. All right, so the other function in here is steep and shallow. If you do a lot of 3-axis surface finishing, steep and shallow is something that is really great for that. What it does is it actually goes through and it determines areas in your model that are steep, which means the orientation of that surface in relation to your z-axis is fairly vertical. So typically greater than 45 degrees, you're going to be using a Z step down. So if you were programming this without the steep and shallow toolpath, you would have to sort of set a threshold angle and try to blend together your steep and your shallow surfaces. With steep and shallow, it does that for you. So it identifies where that transition between steep and shallow occurs. And it actually takes the contour toolpath and it blends it together with the scallop toolpath. So if you're familiar with those two toolpaths in Fusion or Inventor, you've got contour for your Z step down. So it's going to step down with a constant Z. Scallop steps over with a constant step over value, and it's great for doing shallow surfaces. So what you get, if you kind of compare these two side by side, you'll notice as you come down the wall, you've got that constant Z step down. And then right when it gets to that shallow transition point, I think this was set at like 30 degrees for the transition. You'll see right at that point, it actually switches and it starts doing a scallop or a shallow surface machining operation there. So right along that wall, it automatically finds the transition and blends the two together. This will lead to a really nice surface finish, and it's going to be much easier to do it with the steep and shallow toolpath than manually going through and setting boundaries and setting limits. For toolpath modifications, I mentioned this earlier, you can use the trim function to just actually select a boundary. So you'll see this red boundary here. You can highlight a portion of the toolpath where typically this is like near the edge of a part or where you have a hole and the tool is trying to dive into that hole. Rather than go through and create like a sketch boundary, sometimes you've already generated the toolpath and it's only one small section that you need to remove. It's actually going to be much simpler just to delete that section. And that's what trim toolpath allows you to do. You can just select the region you don't want and click trim. It removes those toolpaths and it recalculates the rest of the toolpath to have a nice smooth transition from one point to the next. So it will create new leads and links for you, and you don't need to recalculate the rest of the toolpath. So really, if you do a lot of 3-axis surface finishing, complex surface parts, mold, dyes, things like that, steep and shallow and trim toolpaths are extremely useful, and I think you get a lot of value out of those. All right, now anyone that has a 5-axis machine, you may really be interested in the tool axis editing functions. What the extension allows you to do is modify the lead, lag, and lean of the tool. If you end up using this extension, get comfortable with the differences between lead, lag, and lean. Make sure you learn what's what. Essentially, the lead and lag angle is in the direction of travel. So they show here if you're moving in direction 1, this angle, basically forward or backwards, is going to be your lead and lag angle. So a positive value will tilt the tool forward, a negative value would tilt it back. Lean, so if you have lean and lag, that actually tilts the tool sideways off of the axis. So they show on this surface on the bottom, a angle of 0 means the tool tip will be exactly normal to the surface and perpendicular to it. If you put in a lean angle of -88 degrees, it tilts the tool back up towards vertical, negative 88 degrees. So it'll use more of the side of the tool to finish that surface. So this lean option is really useful when you're machining a surface and you don't necessarily need the tool to be perfectly perpendicular. Maybe you want to use the side of your ball nose mill to get a better finish. These tools allow you to tilt the tool forward and back as well as side to side and find that optimal tool engagement. What you also get is the ability to turn on automatic collision avoidance, which will find anywhere in your tool path you have a collision between the holder and the stock or the tool and the stock. And it will automatically tilt the tool to avoid that collision. And it only tilts it enough to clear. It doesn't, flip it around horizontally. It just tilts it to be clear of your part. The automatic collision avoidance is basically just an easy button. When you use that, it'll automatically avoid collisions, and you're not trying to figure out what lead and lag angle you need. But in some scenarios, you might know exactly what angle is going to make the most sense. You can do that by overriding the tool axis. So the machining extension gives you these capabilities, and when you have a 5-axis machine, you might as well be using it, especially for avoiding collisions. This is a great way to do that. All right, so let's actually get into the fun part here. I'm going to do a quick demo of what these features do and where you can access them in Fusion. So I'm going to be going through these, and if you have any questions as we go, remember to throw them into that chat window, and I can help you guys after we've gone through the demo. All right, we're going to start looking at hole recognition. Again, this is my favorite, and looking at this part that I mentioned earlier. At this point, I have added in all of my toolpaths to essentially just rough this out and clear out all of the material. So I've left the holes for last here. So I need to program the counterbore holes on the boss, and then there's several other holes in here. So if I was programming this without the extension, I'm going to have to go through and number one, I'll probably have to go through and measure these holes because I don't know what these are. So I'll have to go through and measure the hole and figure out what the sizes are. Then I'll have to go into my tool library and go select the tool that I want. And then when I go to create a drill toolpath, I have to go through and select the hole, select all the holes of the same diameter, and then select my cycle and click OK. So there's a bit of work involved when you're using the standard drill toolpath. It works fine, but if you have a lot of holes, it can become really cumbersome. So hole recognition, if you have the extension, you'll see it shows up next to drill. I can click hole recognition, and you'll notice what it does. In here, you get a table. It tells me all the diameters that it found. So these are all the things that it thinks are holes. And it gives me a recommended toolpath to use. So in this case, the 1/4 inch diameter, it says spot drill and drill. It highlights them in the window, so I can see which ones it's specifying. The 201 holes, it found that there are 7 of those, and it's recommending a spot drill and drill. That should be fine. Now the 1.5 inch and the 2 inch holes, anything that's bigger than 1 inch, usually it's going to give me a recommendation to ignore it. And that's correct, because I've already done those with a flat end mill. So I don't really need to drill those out. If you want to program them, you can override the default here with whatever cycle you want. And then lastly, there's these counterbore holes up here. It's recommending a spot drill, drill, and counterbore. So it's going to spot, drill, and then come in with a flat end mill and bore out the counterbore. So we should be set with those toolpaths. Now, you can go through and specify exactly what library it is allowed to use. If you let it use the sample tools in here, the problem is it might select a tool that you don't actually have. So what I would recommend doing is creating a tool library with all of the spot drills, drills, and taps that you have on the machine or you have in your shop. That way, when it creates this hole recognition, it's only looking at tools that you actually have. In this case, I'm using all the tools available. So it's going to be able to find what I need, but it is best to create your own custom library. And then for options, I can say find by a specific angle off of axis. I can also find by diameter, which means I can basically specify the diameter that I want it to find if it's one hole that I'm looking for. You can limit to the setup plane, or you can specify a angle, which means if I had holes that were on, like for instance, this chuck here that I was drilling out, you can actually override the position of the holes that it's looking for. So if you have a different setup plane that you need to recognize holes on, you can do that using that function. And you can also group operations by size, or you can minimize tool changes. So in this case, minimizing tool changes means that it's probably going to try to do as many spot drills as it can before changing tools. If you group by size, it'll finish each hole size with all of the features before moving on to the next one. So if I click OK, just like that, it programmed all those holes. So it went through and it found a spot drill for the counterbores, a through drill, and a bore. Spot drill for the smaller holes, and then it actually added a chip breaking cycle, so a pecking cycle to drill through that, and then a spot drill and pecking cycle for the 1/4 inch holes. So it did all of those in about 10 seconds, no problem. And I can post this out to G-code, and I'm ready to run it on the machine. So big time saver, fully automated. You don't have to go through and measure. You don't have to go through and select tools. And again, it's just a really nice, smooth function to work with. So it groups them together in one single toolpath here. You can just delete them all together and modify them individually. For instance, if I needed to change the lead in or the lead out for one of these, you can just go and double click on the toolpath and modify it just as you would normally. All right, on to the next one. We've got a lot to get through here. So this is a part where I would recommend using steep and shallow. So let's go ahead and look at some of these surfaces here. You've got some steep walls. You've got some walls here and here. They're going to have some steeper surfaces. Down in this section, we've got these fillets and this angle. Pretty shallow. You know, that's not going to be hard to machine straight on. Should be able to use a scallop toolpath for that. And then in here we have some mixture of shallow and steep to work with. So traditionally you'd have to go through and use a contour and a scallop toolpath and try to identify where you want that cutoff angle to be and try to blend them together. With steep and shallow, you don't even have to worry about that. I can literally just go in here and select steep and shallow. For my geometry, I'm going to select this inside boundary here, so everything on the inside of my mold. And for passes, let's just use a really coarse step over and step down so that this generates quickly, and then you can come back in and refine it later. So we'll just do like 1/8 of an inch so that it generates really fast here. So I'll click OK. What it's going to do first is it's going to identify what surfaces are steep, what surfaces are shallow, based off of what's called the threshold angle, which I'll show you guys in a second. And then it will automatically add in your scallop and contour. So once it's done generating, you get this toolpath here. And if I zoom into the side, you can see on this wall here, it's using a contour. And then as you get down to the flat, it switches to a scallop and it blends those two together. So you get a nice transition. Same goes for up here, it's using primarily contour, and then when it gets to this rounded surface here, it switches to using a scallop. So it'll automatically locate and blend that toolpath. Now, if you feel like the transition occurs at the wrong angle, on your passes, you can come in here and modify this threshold angle value. 30 degrees means that anything less than 30 gets scalloped, anything greater than 30 degrees gets contour. So if I bump this up to 60 and I regenerate, that means that I'll be using more scallop, which means I'll see that scallop toolpath start to creep up that wall a little bit and start working on some of those steeper surfaces, anything that's 60 degrees or less. So I can see now the scallop comes up a little bit higher along this wall because I'm allowing it to machine anything 60 degrees or lower at this point. So steep and shallow, another great toolpath in that extension, a good one to check out. And again, you can trial these for 7 days, or you can purchase them for a limited period of time if you just want to experiment a little bit and see if it's actually going to save you time and headache. Let's look at the toolpath trimming. This one's pretty straightforward. This toolpath here was just run as a parallel. And so you'll see as it steps over, it all looks pretty good. But then on these holes, I've got a bit of an issue because you can see on like some of these, it's sort of overlapping where it's coming over the top of the hole. And sometimes you'll get these lead-ins where it's kind of air cutting. Sometimes you might see it actually dip down into this pocket and try to machine something at the bottom, which can also be problematic. So if you want to clean this up really quickly, what you can do with toolpath trim is I can just select a boundary. So I'm just going to use a polygon and just kind of draw this out. Let's say I want to clear up the inside of the hole. I can just come in here and just kind of loosely draw the boundary that I want to cut away. So I don't want anything inside of that hole. Just right click and select OK. It's going to delete those sections and it's going to recreate the lead in and lead out to be nice and smooth. But you'll see how quickly it did that. That's because it's not modifying any of the toolpath out over here on the sidewall. The only thing it's doing is modifying that section and adjusting the lead in and the lead out to be nice and smooth. So now I don't have those little swoops in there where it's trying to machine the edge. It should be a nice, smooth transition from one side to the next. So it's really as simple as selecting trim, drawing your boundary, and then selecting OK. And then if you ever want to undo it, you can just click back, and then it'll add back in what you had. So it's easy to keep track of. So then it added that right back in. Now, the other option here is delete passes, which is a little bit more powerful if you need to take out an entire chunk. So here, you see how it's rolling over the edge of this, this curve. If you want to modify that, rather than try to draw a boundary, I can actually delete entire passes as well. So with delete passes, you just have to highlight what you want. So in this case, let's say we highlight a couple of these guys here. It selects all of those at the same time, so I can kind of go through and window select the ones that I want. You'll notice it grabs the entire pass as opposed to just a little section of it. And then if you click OK, it takes out the full pass, not just the segment. And so you see it cleans that up and backs up even more. So that's usually what I'll use if I need to take out a larger chunk of the toolpath rather than trying to create a boundary. I'll just group select all of those at once and then select OK. And it'll just blow those right out of the toolpath and I'm off and running. So good cleanup tools if you do a lot of 3-axis surfaces. Another thing on this toolpath is you'll notice the sidewall here, pretty steep. It's going to be tough for the tool to get in there. If you want a good surface finish, you might be using a kind of a stubbier tool. If that's the case, you might have some collision issues. So I created a toolpath to machine that sidewall here. And if I simulate it and I stop on collision, you'll see it works its way down the wall okay, but then it gets to a point where it just can't quite get the tool in there without hitting the holder. So I speed this up a little bit, you'll see like right in there, it collides. So if I zoom in here, you can see the holder just kind of clips the top of that wall. And this is just the first collision. You can see along the bottom here, it's just gonna keep colliding as I go. Basically, I'm gonna destroy my my tool and my holder. So in this point, I'm gonna need 5-axis to get in there and actually machine that. So there's 2 ways to do it. Number 1, in your toolpath for steep and shallow here, you'll see on multi-axis, the primary mode is vertical, which means it's gonna keep the tool at a vertical position. If you check the box for collision avoidance, what it does is it automatically tilts the tool to prevent collisions whenever they happen. And you can specify here a smoothing distance, which means if it tilts the tool, the smoothing distance controls how long of a cut it uses to blend from vertical to the new angle. So if you have a really short smoothing distance, what that means is the transition from vertical to the angle is going to be really quick. So the tool is suddenly just going to flip to an angle, and you might get an unusual surface finish when that transition occurs really rapidly. So if you want to blend the transition of the tool from vertical to the angle over a larger distance, you can increase that smoothing distance. There's not a value that works in every single scenario. Obviously, it determines the smoothing, but it also depends on the size of the part. So what I would recommend is kind of experimenting with the smoothing distance until you feel like the transition is in a good spot. You're not going to get any rapid tool adjustments. The default is usually pretty big, but you can always size it down or size it up as you need to. So automatic collision avoidance will look like this. You'll notice now when this machines, as it gets to the collision areas, you'll watch the tool. I'll slow this down a little bit. As it comes around where it originally collided, if I look at it from the side, the tool is now tilted to achieve clearance between the holder and that sidewall. So each pass now, it tilts the tool just enough to clear by a few degrees. It's never going to cut it too close. So you get a really nice smooth tool path that avoids collisions. And I didn't have to go in there and do anything. I just checked a box and it automatically adjusts the tool to avoid any damage to the holder. And it simulates all the way through to the bottom without any collision. So I was able to maintain that all the way to the bottom of the pocket. So pretty nice function there. The other option, in addition to collision avoidance, is the ability to change your primary mode. Now, these are 5-axis capabilities that come over from PowerMill. One thing you can do here is select lead lean. With lead and lean, I can specify a lead lag angle. Remember, that is in the direction of the tool, so tilting the tool backwards or forwards in the direction of travel. Or lean angle is out of plane, side to side. So if you're moving in direction 1, it's tilting it out of axis along the X or Y. You can adjust those and it locks that in. So it's going to go from vertical to that angle over whatever your smoothing distance is, and it will lock that position in, which means you can maintain sort of a constant tool orientation. So for this tool path, let's say that I want to lean it, right? If I do a lag or a lead, that's not going to do anything for me here. I need to tilt the tool sideways. So in this case, it's actually a negative direction. So tilting it to the left from this perspective, negative 60 degrees means it's going to tilt over to the side and help me obtain a little bit more clearance. The advantage of this is that it keeps it at negative 60 degrees from the beginning, so that I'm using the same tool position on that wall the entire time. It's not going to be changing during the cut. So if I look at the tool path for that, you'll notice the difference here is it doesn't start vertical. It starts at negative 60 degrees at the top of that cut. Even though I don't have a collision, you'll notice it's going to be at 60 degrees as it cuts through that surface, even though at the corner it's going to tilt to meet that new angle and come around that corner. But during this machining of this sidewall here, it keeps the tool at 60 degrees. So it's locking in that angle and maintaining that constant tool engagement. So collision avoidance just does it automatically. It will obtain whatever angle it needs to maintain clearances. Tool axis editing, you actually specify an exact angle you'd like it to maintain. All right, 2 more things here. Rotary. So anyone that has a chuck that you can mount up on your mill, you might consider getting this rotary toolpath. If you have a part like this where you can primarily turn this down on a lathe. So if you're actually working with a lathe, you can turn the stock down to almost the exact part, but the only thing is these little corners, these cutouts for this gear kind of shape on the end, as well as the star shape in the middle. You're not going to be able to do those with a lathe. You're going to need an additional axis to do that. That's where rotary comes in handy. With rotary, I can actually run the tool along the surface in a spiral or a circle, or I can run it along the axis in a line and machine out all of this material after it's been turned down on the lathe. So with rotary in here, if I go to multi-axis rotary, I can specify spiral, line, or circular. What spiral does is it is going to be a continuous cut, so a continuous spiral working its way around the surface. A line is going to move along the axis, so along that Z orientation, along the axis, front to back. Circular is going to be just a perfect circle. So it'll step over and then do another circle. It doesn't link together the toolpath like the spiral does. So if I do a spiral with a step over of 1/8 of an inch on this part, it's going to look like this. Basically just working its way around. If I turn off the stock, the tool just works its way around. And in reality, the tool would be stationary and it would be rotating the part. So it's going to simulate like this, but in reality, the part would be spinning and the tool would be stationary. And this is just going to be a constant spiral all the way around, machining out that material. Now, if you use the line function, again, it's going to switch to running along the axis. So along, in this case, the X. So a little bit different. This would be if you have a scenario where maybe you have some deep grooves along the X that you can't quite get into. You might even consider combining these two together to machine everything out, kind of do a crisscross waffle pattern. But what you'll see is it's basically going to just run along this surface, diving down into each pocket as it goes, running horizontally along the part. So in this case, what would actually happen is the tool remains stationary, it moves in and out, but the part is going to rotate to each of these angles. You'll see in here there's a step over value. That's the step over that it's going to make in between each cut. So it's going to rotate the part 5 degrees at a time. So if you want a tighter surface finish, you would bump that degree value down. And then lastly is the option to do circular. With circular, again, it's going to not link them together. So it's basically going to look similar to spiral, but it breaks it up into individual passes. So after each pass, it steps over. So it's going to run around, step over, and then run back around the other way. So it's not continuous. It does step over in between each pass, but this can work really well for these types of parts as well. Now, the other thing you might consider doing is you can actually come in here and limit where the angle of the cut is going to be. So if I don't want to machine all the way around the part, you can actually set angular limits. So let's say from this point here, I want to machine 90 degrees. I can type in 90 and it gives me a 3D preview. This kind of blue wedge here shows me the portion of the part that I'm going to cut. So if you limit it by an angle, it's only going to add toolpaths inside of that region. So I click OK. It's still going to create a circular toolpath, but it stops when it gets to 90 degrees from that point. So then it will only machine that 90-degree side of that surface. So this is helpful as well if you only have one pocket, like maybe your part isn't symmetric around the axis. You can limit the toolpath to only the area you need to cut. That way you're not air cutting and you're not machining into pockets that you don't need. That angle limit is a really useful tool for the more complex parts you might run into. All right, and final strategy of the day is probing. With probing, you can probe for 3 different things. Your work coordinate system, which would mean you're probing for where the X and Y and Z are for your G54 on your machine, so your stock work coordinate system. Or updating a coordinate system. So if I click WCS, maybe I want to update the coordinate system off of the feature that I created, I can actually select these 2 sidewalls, and it gives me an XY corner. So that will locate this corner, and then I can add another probe feature to locate this surface. So I could create a new WCS where I update the corner position here, and then another probe to locate the Z surface. The other option in here is probe geometry. What this allows you to do is probe a specific feature. So let's say I want to locate this cylindrical boss. I can select it, and it's going to locate that boss, so the center point of that boss, and it'll tell me if I am within position or not. So these tolerances down here, 1 millimeter for the position, 1 millimeter for the size, means that when I probe this in process, which means I finish making the cut, I load my probe, and I add in these probe locations, it will then give me an error message that I am out of position or I am out of size if the position or size is more than 1 millimeter off. So you can actually go to the Actions tab, and I can say, if it's out of position, stop the machine and give me a message saying that it's out of position. If it's too big or too small, outside of that 1 millimeter tolerance, I can have it output a message that says it's the wrong size. You can also update your tool wear. So if you want to just use the probe to update the tool wear and how much compensation you need, you can do that. You can also have it print the results from your probe. So generally, these are the 2 that are most commonly used. Just come in, specify what your acceptable tolerance is on the machine, specify what you're probing, and then it will give you that message on the machine in process. And the advantage of this is that you don't have to take it off the machine, inspect it, and then put it back on the machine. If you have a probe loaded up, you can probe it after you're done finishing it and make sure that it's acceptable before you even unload it from the machine. Now, the other feature you get with the machining extension is the ability to inspect surfaces, and you can actually import results from your inspection and compare them with the points you collected with your probe. So let's say I want to inspect this surface right here. I can add a chain of points like that and inspect those 5 points. Now, the results that I generate on the machine, I can then import back to Fusion 360, and it will show me the results from the manufactured part, how it compares with the CAD data, so where the location of that surface should be. So for instance, this corner, let's say I'm probing the location of this corner here. I've got the top surface and the 2 side surfaces. Let's say I want to probe those locations and make sure that they're correct. You can add a probe for all 3 of those, so top, side, and Y direction. And then you can import results. And when you click on Show Results, it will then give you your nominal X, Y, and Z position of those points, where those surfaces should be. It then gives you the delta X, Y, and Z from your inspection, so the inspection that was made on the machine. And then it will give you a deviation, and if it's within that tolerance that you specify, it'll give you a green dot here. So all of these are, the first one's outside of 0.014, the other one is -10, and then the final one is 0.004 off. It shows those deviations, and if it's below tolerance, it'll show up red. Above tolerance, it'll show up blue. And those dots are displayed in 3D. So you can really quickly look at a part and see if a surface is in tolerance or not. And you can get these hard values here from the inspection results that you import back to Fusion 360. So much more capability than the standard platform of Fusion has. You have the ability to not only create those in-process probes, but also compare the results directly in Fusion 360 without the need for another software. So that's it for the machining extension. Again, to access this, at the very top of Fusion 360, you'll see this little, it looks kind of like a plug, like a power cord plug for an outlet. If you click on that, it opens the extension manager. It has all the extensions listed here. And if you click on the extension, it gives you a summary of what it is and then the access options. So you can purchase this one with a credit card. Machining, I have 25 days remaining on my trial that I'm doing currently. It'll give you an update each day, and then you can just go through and kind of experiment with what these are and decide if you want to purchase them and for what period of time. So reach out to the IMAGINiT team if you want to get a more detailed demo of the extension, or if you want to purchase it, let us know. But hopefully this was informative and you guys learned a little bit about what's in the extension and some of the applications of that. All right, so I'll wrap things up. If you have questions, there's the email, info@ran.com. Feel free to reach out. And then if there are any questions from the chat for the Q&A here, I'll answer those now.